Hey guys, let's understand another very interesting and important problem, that is container with most water. So the approach will be similar. We'll understand the problem, then I'll try to make you understand the algorithm. Then we'll see the step-by-step execution of the code, how it is working in the backend. So let's get started. Let's understand this problem. So problem is very straightforward. It says you have given an integer array height of length n. So you will be given here in the input, you can see you will be given an array of length n. In this scenario, 1, 2, 3, 4, 5, 6, 7, 8. So this is the length is 8. So likewise, it could be till n, whatever it is. So what the integer will denote? The integer will denote the height for what? Height for the vertical. Like in the next we'll see there are n vertical lines, so height for the vertical lines. Okay, and then we will be given the two endpoints for the ith line. Suppose this is the first line, this is the second line, this is the third line, the fourth line. Let's say this is the ith line. Okay, so for ith line you will be given the coordinates. So this is the first coordinate I0. So this is I0, and this is the second coordinate. This is what will be given. So that's what they have seen. Okay, now what they are saying, find two numbers, sorry, find two lines that together with the x-axis, they are saying find two lines that should be with the x-axis, and how that line will be such that the container contains the most water. So that line should be something like, if we are taking an area between those two lines, that should be the maximum area which will contain the maximum amount of water. That is what their requirement is. So as from this example, you can see, right? So in the very first scenario, we will have 1, and here we have 8. So from this, what we can make? We can make this, in this we can trap the water. Okay, in the next line, we can see we can trap the water in this. Okay, so in this next line, again, we can see we can trap the water in this. So likewise, whatever the all possible scenario which we have to go through, and we have to look like where we can store the maximum amount of water. So in this scenario, you can see we have a line till 8, and here we have a line till 7. So this clearly represents that in this, between this, right, between this we can store the maximum amount of water. So that is what they mean. So how that will be, this 8 and this 7. Okay, so between these two they will make. So how we are going to calculate this? This is very simple calculation. We will get the length of this. Length, how we will be getting, like we will be getting till this point to this point. How we will get the length, we will see later. So we will get the length till this point, and we can get the height of this, and we can multiply that in that. So in this scenario, we'll take 7 from this. The height is 7, and the length is also being 7 over here. Okay, so we'll see how that 7 came. So this is what their problem statement. So let's try to understand the algorithm, how we are going to approach it. So this problem can be solved using different method. First, it could be of brute force. That is very obvious. So that will be like more time consuming, like the time complexity will be 4, and n square will be the time complexity. Again, if you are, again, you can solve this using dynamic programming also. That is also not efficient way to do this problem. Okay. Uh, so the best way to do this is like, in this type of problem, you will get two pointer, right? Two pointer concept will be the best to solve this. So basically, what we will have in two pointer, we will get the two pointer. One will be at beginning, one will be at last, and then we will do all the manipulation with this two pointer. So how that will be, let's understand that. So what we will do, we will start with the two pointers, one at the beginning of the array. We will just call it as left. Okay, we will keep a pointer at the left. Another will keep a pointer at the last. That will be right. Okay, then what we will do, we will calculate the area till to this. So how we will calculate the area? Whatever the minimum, like suppose in the very first scenario, we have 1 and 7. So left is sitting here, right is sitting here. Okay, so we will get left or right. And whatever in this left and right, whatever is the minimum, suppose in left we have 1, right we have 7. So in 1 and 7, which is minimum, we have 1. So we will get 1, and then that 1 will be the height of this, and then we will get the length of this. So how we'll get length of this? We will get the length of this by doing right minus left. Okay, so our formula will be right minus left. Okay, and after that we will multiply this right minus left by height of left, uh, height of left, and height of right, whatever height we have here at right. Okay, just this is a comma in between. So this is height of left and height of right. So from this left and right, we will take the minimum, whichever is the minimum. So in the very first example, 1 is the minimum. So we will take 1, and in this right minus left, which will be coming as 8 over here. So 8 into 1 will be 8. So in the very first time, we will get the area as 8. Okay. So likewise, the iteration we will repeat till left is less than right. So that is what our algorithm will look like. Okay. So I think it will be getting more clear when we will be understanding in the debugger. So yeah. So and additionally, what we will do, we will update the maximum area font so far, like whatever the max, suppose in this case, the area which we got is 8. So we will store this 8 into any variable, that is just keep it as max area. So we will store in the max area, and then we will move the pointer with the smaller height toward the other pointer. This is why, because moving pointer with the larger height will not increase the area. Okay, so let's suppose we got 1 here, we got 8 over here, we got 7 over here, 1 over here. So if this is a smaller, then we will move the left to left plus plus. Why? Because if we are doing a right minus minus from here, then we will leave this big big vertical line. That is not a feasible scenario. Then we will lose the record of the maximum area. So wherever we will have the lesser, right? So in this scenario, we have 1 over here. So wherever we will have the less, there we will move it. If here we have less, we will do right minus minus. If here we have less, we will do left plus plus. This is what we are going to do. So I think it will make more sense to you when you will see the in the debugger mode. When I will explain you there it will make more sense. Let me clear the drawings. We will go to this and we will understand this. So very straightforward, I will explain you again the things. So we have defined a max area. So in max area, we are initially keeping at 0, that the area being 0. Left, we are keeping at the 0th position, and the right we will keep at the length of that, whatever the length which we got, height dot length, whatever the length of the array is, that minus 1, we will get the length of that array. So we will keep at the last position. Okay, that is what we have seen there, right? So suppose we will keep left over here, right over here. That is what this 2 will do. So we will again run a while loop. How that while loop will react, we will understand this. So the condition for this while loop is left is less than right. What does it mean, right? As long as left become less than right, till that point we will be doing this iteration. Okay. And in the next line, you can see how we'll be calculating the area. So as I have told you, right, height of left, height of right. So whatever the minimum which we have in this scenario, as we have seen, 1 and 7. In 1 and 7, we have 1 as minimum, 7 as the more. So we will take 1 out of this. We will take the minimum of these two, and we will multiply this with right minus left. So right minus left in the very first scenario, we will get as 8, as we have seen here. Okay. So yeah. So max area, whatever the value will get, suppose 8 into 1 we got. So 8 will be the max area in this. So we will be storing that max area. So whatever the current, so max area defined here as 0. Okay. So 0 will come here, and current area, what we got, 8. So current area and max area 0, 8, max is 8. So we will store the max area as 8, and we will update the max area variable details. Okay. So yeah, next what we will do, we will move the pointer corresponding to the sorter line inward. So wherever the sorter line will be, as we have seen there, right? If height of height of left is less than height of right, then we will do left plus plus, or else what we will do, right minus minus. So if it is left is less than the right, then we will just simply move the left to the one position forward. In the other scenario, we will do the right minus minus. Okay, and at the last, whatever the max area which will be stored in this variable, we will return it, and that's what the answer will be. Okay, so I think it will make more sense when you will understand with the unit test. So let's understand this. So this is the input which we are passing. We are passing the same input which we have in the Leetcode. So this input is being passed 186254837, and the expected is 49. That's what is expected. And we have seen the area between 8 and 7. We will get 7 from here and 7 from here, and we will multiply that 7 is to 7 is 49. So that's what expected here, and expected, and we are just calling the solution max area by passing these heights. So yeah, we will run this. I kept already a debugger point to the max area below function, so it will directly go till that point. Okay, see, it came over here. So height, whatever we have passed in this height, it came here. We got the height in the very first iteration. We are like in the very first time we are doing few initialization. So I will just go next line. We initialize max area, we initialize left, and here we are getting the right. So right we will get here as 8. Okay, so that's what we have seen. So as long as left is less than right, so here in this scenario, left being 0, right being 8. So this is satisfying. So this is true. We will get inside this. Okay, so now the thing is, we will calculate the area. So see how we are going to calculate the area. So height left. So height left in the sense, left is 0, height of 0 is 1. Okay, so we will get 1 over here. Okay, let me write it down also. We will get 1 over here. Okay, and we will get height of right. What is height of right? That is this last one. So we will get 7 over here. Okay, and right minus left. What is right? 8 minus 0, which will be 8 only. So this will be 8. So from these two, what is the minimum? Minimum is 1. So we will take 1 and we will multiply that one with 8. So in the very first time, we will get the current area as 8. So that is what you will see. So we will go to the next line. You will see it became, current area became 8. Okay, so let me clear the drawing. It will confuse you in the next iteration. So I cleared it out. So I think you are able to visualize it, right? So current area being 8 here. Now what we will do, we will get inside the max area and current area. So max area defined initially as 0, and current area, what we have, 8. So 0, 8, whatever the max which we have, 0, 8, 8 is the max, obviously. So we will update the max area value to 8. Okay, so you will see max area got updated with 8. So now in this scenario, height of left, so what is being left here? 0. So 0 is less than height of right, 7. So 0 is less than 7. So this satisfy. So this is this condition. So this is less. So we will move this left to plus plus. So this condition satisfied, we will do the left plus plus. We will move this. So this else will not satisfy. It will go again to the next iteration, next loop. So in the very next loop, left plus plus means left will become 1 this time. Now we will check for the 8, this 8. Why? Because left is 1. So height of left, that is height of left will be 8 now. Okay, so we'll go to the next line. We'll see height of left is 8. So 8 comma height of right. What is right being? Right being also 8. So this 7. So 8 comma 7, which is a smaller. 7 is being a smaller, right? So we will get 7 in this, and this is right minus left. So right currently what we have 8 and left is 1. So 8 minus 1 is 7. 7 into 7, that will be 49. So current area, you will see when I will do next line, you will see current area will come as 49. Okay, so 49 again, it will come max area. What we have in the max area 8 comma 49. 49 will be whatever the maximum will take, 49 being the maximum. So max area will be updated to 49. Okay, so in this scenario, what we will do, height of left, that is 8, and this height of right, that's 7, which is a smaller. 7 is smaller. So this time we will move, we will come to the else block and we'll do the right minus minus. You will see right minus minus. So this right will become 7 now. Okay, so yeah, In the very next iteration, again, we will go to the while loop. This time, left being 1, left will be sitting at this 8, 7. This will come to 7. That means this will come one place. Uh, this will move one place backward. Okay, so this came over here. It will be at 3. It is now again, we will go, we'll get 8 as left, 3 as right. So what is minimum? 3 is minimum. We will get right minus left, which is 6. Okay, 7 minus 1 is 6. 6 is to 3, that is 18. We will get 18 as the current area. So max area being 49, current area being 18, which is maximum, 49 being maximum. So we will not touch max area. We will keep the max area at same. In the very next iteration, again, we will compare the same thing. And again, it will come to right minus minus. Why? Because this is less. So again, it will come to 8. Now, right also being at 8, left also being at 8. So again, we will come here, left being 1 and right being 6. This is the position. Don't confuse with position and the height. Okay, so yeah, when we will go at this point, height left, uh, so left value being 1, that is 8, and this is being 6, which is 8. So 8 comma 8, which is minimum 8, we will take just 8, and right minus left, 6 minus 1, 5, 8 5 is 40. So 40 will be the area in this scenario. We'll get a current area as 40 and max area as 49. So which is maximum? 49 is maximum. We'll store that inside that. Okay, let's go to the next. Again, the else block will come and we will do the right minus minus. It will become 5. It will come over here. Again, you can see, right? I think you can visualize it. So it will come over at this point. This is sitting over here. Again, we will compare 1, 8 and 5, which is a smaller, 5 is a smaller. And what will be the 5 minus 1, 4. So 5 into 4, we will get as, sorry, 4 into 4, we will get as 16. Okay, so yeah, this is 4. 4 is a smaller, 4 compared with 8. 4 is a smaller, so and 5 minus 1, 4. 4 for just 16, which is a smaller, 16. So we got it. So current area updated to 16. Now max area is 49. So which will be considered, whichever is the maximum, we'll take that. So you can see the same way we will do the, I think this is making sense. I'm making bit fast here. So yeah, this is how it will be. At last, you will see the left and the right will, so left became 1, right became 2. Still, left is less than right. So this is true. This is the last iteration we will go through. And now after that, left, this doesn't mean, right? It doesn't make sense. 1 is less than, so it will come out of this. So max area, what is there in max area stored as 49. So this 49 will be returned. So we will get the expected over here as 49. Okay. So this is what, this is how we can solve this. So I think it is very clear forward. So I think you can try the other test cases too by running it in your local. So I will clear the debugger and let's take this. We will keep the same over here. Already this video went too so long. I'll keep this here. I will just run it. Yeah, so we got it. So this is how we can solve it. And this is very like very this is power of 2-pointer. With the help of 2-pointer, we what was the time complexity which we got in order of n. Okay, so that is what the power of this, and space complexity will be constant here. So this is very popular problem of 2-pointers. So yeah, that's all. Thank you everyone. See you in the next video. Bye bye.